Hi, I'm Kelsey Wimberly, and I'm going to talk through the work I did in my graphics classes at DigiPen Institute of Technology. To start off, I was given a project with a teapot, some walls, ground, and some bodies of water. The first thing I did was get transformation matrices working for position, rotation, and scaling. This shrunk the teapot and moved it slightly upwards to sit on a now correctly positioned box that was not visible in the scene previously, and caused the teapot to continuously rotate while the scene was running. Next, I added textures to all the objects in the scene, including a sky sphere and a procedural texture on one of the frames on the wall here. To give more depth to textures, I added normal maps to a few of the objects like the bricks here to give the appearance of depth to them. I also created a different kind of procedural texture for the box using simplex noise. I created variables for the ring frequency, thickness, and turbulence to determine how curved the rings look. I made it so that all of these variables can freely be changed in the scene with a few keyboard buttons. With textures in place, I used the BRDF lighting equation to light the objects in the scene. I then moved on to creating shadows in the scene. I added some rotating spheres to create more shadows on the ground, and I created a new shader to record which parts of the scene would be in shadow based on the light's position and direction. I then passed this information to the main shader and determined if the pixel is in the shadow, in which case it is displayed using only the diffuse color multiplied by the ambient light value. I then made the teapot reflect the scene around it. I achieved this with a dual paraboloid map, in which I created two new reflection shaders which drew the upper and lower viewpoints centered on the teapot. These two reflection maps are passed to the main shader to calculate the teapot's new diffuse color. The dual paraboloid map does a good job of reflecting the scene, minus the walls, which don't play nice with the algorithm due to being in both the upper and the lower reflection map. I then moved on to lighting the scene in two different ways: deferred lighting and image-based lighting. For deferred lighting, I created a geometry buffer to store the scene's position data, normal data, and albedo data. I then added numerous randomly placed and colored lights to the scene, and passed these values along with a radius of light to the main shader. With the radius, I then calculated how far each light was from the pixel, and if it was within range to be lit. If it was, that light value was applied to the pixel. In the final forward rendering pass, I then added the ability to show the lights in the scene. For image-based lighting, I was provided with an HDR image to replace my sky sphere. I generated an irradiance map from the HDR image to use in the diffuse color calculations, while the HDR image provided the specular color value. These calculations allowed the object to be lit solely by the image surrounding them. This is what I have been able to achieve with an OpenGL and C++ graphics engine. Thank you for watching.